So let us start with this topic. So why the bridge span or why the design discharge is required? The design discharge is required to find out how much opening or how many spans we will be providing in our bridges in the new construction, and in case there is a change in the stream or the watershed area, or in any case the river origin some extra water is coming, then how it is going to affect my bridge and the safety of my trains. So these are the photographs showing some of the bridge spans, and where because of the higher discharge the bridge span or the abutments have washed away, causing the interruption to the traffic, and which may have resulted into the accident and sometimes have resulted into the accidents also. So just a general point that generally the bridge approaches are kept a bit weaker, so that in case the flood discharge is more than my design discharge, then instead of damaging the bridge, it damages my abutment, and the repair of the abutment because of the earthwork and its filling will be much easier and faster than the repair to the bridges, which is difficult, and if there is any distortion or the pier or something has gone damaged, then the entire bridge has to be rebuilt. So these are the photographs where it shows that because of the higher discharge than our design discharge, the bridge or its abutments have swept away, caused accidents also. Here the bridge, the entire one span has washed away. So what are the different important definitions which we will require while going and studying these design discharge and how to arrive at that value? The highest flood level is known to be the highest flood level which we have experienced or which have occurred, which we generally mark on our bridge side. You should understand that this HFL may not be the design HFL. It may be more than the design HFL or even less than the design HFL. Because our design is based on a 50 years maximum flood which has the probability to occur in a span of 50 years. If there is a flood which increases this 50 years span, there we have made our design that there may be a damage if it is more than 50 years, within the more than the 50 years recurrence level flood. So this is the standard practice, and the CB or chief engineer has been empowered that in case he finds that some of bridges which are more vulnerable, very important, then they can increase the design to recurrence level from 50 years to 100 years. Means in 100 years such flood somebody, I am not able to get your voice. Hello, is there any question?
Mr. Sailen Singh, your microphone.
So
Mr. Sailen Singh.
So everybody should put off their mic unless until they have some question. So the chief engineer or CB can increase the that duration to 100 years, so that during 100 the probability of occurring such flood in that 100 year only once in 100 years. So these are the design spans. Then the bridge definitions, everybody is aware that what is the important bridge and what is the major bridge. So major bridge is more than 18 meter span and clear opening of 12 meter or more in any one span. You will find that this bridge means the 12 meter opening bridge in one span or up to 18 meter span, these bridges will be covered by very simple analysis or by a simple method of as per RDSO RBF 16. We will cover it in next few slides. So what is the relevance of the design? So the design relevance is that it is required to decide the bridge waterway, to decide what will be the foundation, and the protection work required for the bridge sites. That will also, and for the depth foundation or for the foundation design, you will require a flux, freeboard, and clearances. When we will study the how to fix or how to decide the foundation spans, how to decide the spans and the foundation depth, we will get in detail of these items. So it is just for your introduction, everybody knows, and the detail will be cleared during the foundation class. Presently, we are concentrating on design discharge. So what are the substructure code provision? Substructure code provision says that the computed flood with a probable recurrence interval of 50 years. This is our design discharge. And bridges where damage is likely to have severe consequences may be designed with flood recurrence interval of more than 50 years. This will be decided by the CBE or PCE. Similarly, for the bridges on less important line and sidings, are you getting the slides? So
Yes, sir.
you are getting that, no? Okay. So bridges which are less important can be designed for just one minute. Bridges which are less important can be designed for the flood intervals less than 50 years. Why these criteria has been kept? Naturally, it is on the economy criteria. If as soon as you increase the period of the recurrence interval level, the design discharge will be more. Naturally, the span, the foundation depth, protection work, everything will be on a higher side or on a bigger side, requiring more expenditure. Then what are the conceptual methods for designing that? It is from the actual data or by a statistical method or a unit hydrograph method. I will just give a brief explanation of unit hydrograph. Unit hydrograph is nothing but a graph between the discharge and the rainfall. Whatever rainfall is there, as per that rainfall, what discharge comes in the river, it is plotted on y ordinate. There is the discharge, and on x ordinate there is time. A graph will come. This is called the unit hydrograph. How it will be used will be covered in next few slides. This is, and another word is the synthetic hydrograph. The same thing. The meaning of the synthetic is because we have considered it as we have manipulated it or we have constructed it based on certain assumption. That is why it is called the synthetic hydrograph. Though unit hydrograph, as mentioned in C, is as per the actual site consideration, what we have received at site. Then the other method is also there, that is a stage discharge relationship. I will just give you the concept and what is the basis for that, but we will not go in detail for those. We will be covering in these classes only the synthetic hydrograph method and also a shortcut method which has for a smaller catchment area which has been developed by RDSO and in the name of RBF 16. So Just a simple explanation of those paras. Then when the stream flow records are available for more than 50 years, then by analyzing those results, we can find out what is the 50-year maximum flood interval, 50-year recurrence level flood interval, which is that design value. If the data is not available for 50 years, but it is available for a sufficient period of time, then by deploying the different statistical method, we can arrive at that Q50, means 50-year recurrence interval level flood discharge. The third is, if that is not available, but we have got data for rainfall pattern, its intensity, and the discharge at particular point, means at a point where we want to develop our bridge. If that is there, then we can develop a unit hydrograph, means discharge versus time hydrograph, and applying the appropriate design storm, we can find out the the design discharge for that area. This method is called the unit hydrograph method, because this hydrograph is particularly for that catchment area and that bridge location. The same thing, but it will be most wise, and actual data can be arrived by this unit hydrograph. But why it is not possible? But it is not possible for all the bridges and for all those locations that this data is collected for a sufficient period of time. That will take time. It will be very, very costly. So what has been then mentioned, that the Central Water Commission, RDSO, IMD, they have developed some module, and in those modules the empirical relations have been developed based on different rain gauges spread over on those area, and where the rainfall and discharge has almost for that area, those areas zones, a synthetic unit hydrograph has been decided. So this is the synthetic hydrograph being used for most of the cases, especially for area which are more than 25 square kilometer, but generally less than 2500 square kilometer. And mainly almost all our bridges will come under this, except like Ganga, Yamuna or Brahmaputra, which are major bridges for which there are the CWC has developed many methods by stage discharge, finding out the old results. By analyzing those results, we get the data for the design discharge for a particular location. Similarly, for the catchment area, which is a small, generally less than 25 square kilometer, RDSO has developed a very simple empirical formula by which we can find out the desired discharge. Let us see further. This is the stage discharge curve, in which the area or the cross-sectional area of the river is gauged. There are different stages, there are different scales which have been provided, and based on this flood location or the flood level, we can find out the discharge. There is otherwise, if we can find out the estimated slope of that area by the Manning's equation, we can find out the flood discharge. The same thing has been shown that this is the method of finding out the flood discharge. These are the scales over which the water level you will find, and finding out the stage on the y-axis you can find out the what will be the discharge. Now coming to the physical interpretation and how we go to arrive at the design discharge, we have interpreted it from the very basic. So there is a catchment. Catchment has physiographic parameters and hydrometeorological parameters. So this is a catchment area, and when the rain occurs, then the water will come down from the higher slope to the downstream. Like here is the blue location, blue line. So if I have to construct a bridge at this location where my pointer is, the catchment area has been covered by this blue line. But on the downstream, I have to cover a bridge on the downstream location. Then the catchment area will be bigger, and that has been covered by the red line. So naturally, this stream on the downstream side has been added by two parallel substream. So the discharge will be more, and you have to have a bigger or higher bridge at this location. For the analysis of this catchment properties, we will require some physical parameters. I hope everybody is having a pen and paper. So please, that CG of this area is the A, CG of the catchment. What is the CG? Here is the CG. Length of the longest stream. So this is the bridge location. This is the longest stream. So the length of longest stream L, length of a stream from nearest to CG to the bridge site. So this length LC here. So this length LC and equivalent or a statistical stream slope. This word and how it is to be decided, we will cover in next slide. It is not a normal slope, but a formula by which this statistical slope is calculated. These all parameters we will use during calculating the discharge. Contour lines everybody know, but I will just explain, just to refresh the memory, that contour lines are the lines where the elevations are same. Like this is the contour line of 40, 30, 20, 10, and these contour lines, when plotted on a paper in two-dimensional, it comes like this. And these contour lines and the diagram or the graph or the photo which is there is called contour diagrams. This is a topographical map, and this topographical map has the contour map illustrated with contour lines. This is being used for deciding the physical parameters what I have covered in the earlier slide. Previously, it used to be in the hard copies available and issued by the Survey of India. Now, there are that site has been given below. On this site, these contour maps are available and can be downloaded. These earlier contour maps used to be quite old, which are 10 to 15 years old, 30, 40 years old maps are there. But these contour maps which are available on the site are from the satellite images are almost very recent, only 2 to 3 years old. So they will give you a better data. So this is the top sheet, how you can reach there, and this slide will come. There will be a detailed class day after tomorrow where how to use this site to find out these parameters by using the Bhuvan map, the Bhuvan map and Google Earth. That will be a complete full class, but I am just giving some slides for that by digital methods we use Bhuvan site, then use the Earth Explorer, and by using these two sites we delineate catchment area, contour, stream length, center of gravity, everything is found out, and thereafter you have to use it in the calculation or the method which I will be teaching today. This is only the Bhuvan site. You have to use the hydrological product map, and then you will find all data. But this is just for your information. This will be covered in detail. So don't bother for this site or try to write down the name of these sites. Now coming to the subject again, that for this entire country has been divided in 7 hydrometeorological zones, and those 7 hydrometeorological zones have been covered in 26 subzones. Each subzone is having a particular or similar type of reaction or output when there is a rain on that. So these subzones are having the same empirical equations related with the discharge and the rainfall intensity patterns. And these subzones will be used to develop the synthetic unit hydrograph for the locations or for the bridges which are falling in that area. Just for your information, that out of these 7 hydrometeorological zones, 2 zones, zone number 7 which is Western Himalaya and zone number 6 which is for Andaman Nicobar, still this relation has to be, means the empirical equations for drawings hydrograph have yet to be arrived at. But most of our bridges will fall in this area, so it will serve our purpose. The bridges for a small catchment area lesser than 25 square kilometer, we need not draw the flood unit hydrograph. We will use only this RBF report, which will be covered in next few slides, which is a easier and quicker method to decide the design discharge. However, the catchment area, length, longest stream, these the difference of height, this have to be followed, this has to be found out. Only thing, the statistical slope and the length of the line from the center line, from the center of CG to the bridge will not be required in this bridge, in this method. What is this method? We will see. In this method or in this report, there are certain assumptions which has been made. So the report, the language has been taken from the report that the very small catchment area has not been defined specifically, but has bearing on one or more of the following aspects: size of bridge opening, drainage area, prominence of overland flow, means the runoff which will happen, because the area is small, so the runoff which will happen will be more, and the water which will get absorbed by the earth, that will have a very negligible effect. That almost we have neglected during calculation of this. Though when we use synthetic unit hydrograph, we add both things, the water which will be absorbed by the earth and also the inland flow, means the water which will get directly below the earth. There is always a seepage and water is coming in the stream, so that water is added, and the water which will get absorbed by the earth is deducted during synthetic unit hydrograph method analysis. But in this analysis, these two items have not been accounted for. They say that there is quick response time. What is this response time? Response times means when the water comes, when the water falls on that, and when it reaches the lowest point, from the farthest to the lowest point, when it reaches, that is a less period. That time is very less. So this response time is only 3 hours. So it is for in a very short duration, the water from the farthest point reaches to the bridge side. All this will eliminate the need for accountal of the inland flow or the absorption of water. And because it is a small area and the entire water is coming on the bridge side, therefore there will be a greater influence of rainfall characteristic, and drainage basin having a steeper slope with little or no storage. Thereafter it says that it is used for the catchment area less than 25 square kilometer. And by practical consideration, we will find that most of our bridges will be the catchment area of most of our bridges will be less than 25 square kilometer. This extract indicates that generally the span required for these design calculation are between 0.5 meter to 30 meter. So most of our bridges will come under this direction, and almost all the opening which are less than 15 meters required, the RBF 16 report is good enough to find out, to determine the design discharge for those bridges. So majority of our bridges is covered by this RBF report. So this RBF report use a modified rational formula. Please write down this formula on a piece of your paper. This Q50 is the design discharge with 50 years flood interval. C is a runoff coefficient. I50, I will explain. A is the catchment area in a square kilometer. I50 is the 50-year rainfall. Wherever R50 is there, is the recurrence interval is 50, and R50 is a R50-year rainfall with duration, TC hour duration. What is this TC will be explained in some para. Here I have made the things bold because it is an empirical formula. So you have to keep an eye and note that area is in a square kilometer, though the rainfall intensity is in millimeter per hour. C is a coefficient, so it doesn't have any unit, and discharge will come in cubic meter per second. No, cubic meter per hour, sorry. So this runoff, we will explain runoff coefficient. So this is the runoff coefficient. It has three factors, X, R and F. R is 50-year 24-hour point rainfall. Means this is R Generally R50 is 50-year 24-hour point rainfall, which is to be in centimeter for the area where the bridge is there naturally. F is the aerial reduction factor. What is this aerial reduction factor? By name it is clear that because R50 is a point rainfall. Why it is a point rainfall? Because the data has been collected by the rainfall gauges. Rainfall gauge has been provided at one location, at different location in the entire subzone, and then those data has been collected, analyzed to decide the empirical and to evolve an empirical formula so that the relation between the discharge and the rainfall intensity and its pattern can be established. So this rainfall was a point rainfall. So this point rainfall has to be converted to the aerial reduction factor. So this is a factor which has been decided by experience. And X depends on the soil type and location. Means the soil which is more permeable will absorb more water. If it is a hilly terrain, clay, then the water will run off faster. So depending on that, the X value has been given, and there is a table which we will see in next few slides. First, we will find out back. So I hope you have written this formula also.
Yes, sir.
So, okay. So we will know and about what is the rainfall. So how we will find out the 50-year rainfall? So for this, in the RBF report 16 and also in the different flood estimate reports, there are different maps which has been given for different subzones there, either 24-hour 50, whatever I will say, I will say about recurrence interval of 50 years. So I will not every time repeat 50 years. Means I will say rainfall for 1 hour duration. It means rainfall of 1 hour duration which has a recurrence interval of 50 years. So there are figures have been given for 1 hour rainfall, 24 hours rainfall, and there are few areas where such rainfall data is not available. In that case, for certain subzones, there is no figure where either 1 hour or 24-hour rainfalls are available. Then we have to use the slide which is on the computer screen. This is showing the 24-hour rainfall area for the entire country. If I find a location for which there is no plate or where there is no drying of 1 hour or 24 hours duration, then I will use this slide or this figure. Here you see that a small inscription has been given, and these lines which you are seeing are the isopluvial lines. Means these lines are showing for the same rainfall lines have been shown. In case we want any area between these two lines, then we have to interpolate between these two isopluvial maps where there are these two figures are there. So under these two figures, I will just try to show you some figure. No, this will not be visible. So in the next slide you will find it. There is nothing. So in this rainfall, the already rainfall data, you will find that the data or the line, the value which has been given on those isopluvial lines has to be multiplied by value 1.15 to get 24 hours rainfall. 14 minutes is nothing but 24 hours rainfall. Similarly, for this is just for example that this slide or this figure is for Kaveri Basin, that is a subzone of one of the zone 3. This shows 50-year 24-hour rainfall. Here perhaps you are able to see these values. This is a 160 value, isopluvial line of 160, then this isopluvial line of 180. If I want anything at this location, I have to interpolate between these two values, between the rainfall between 160 to 180. It means it will be more than 160, less than 180, and you have to calculate by symmetry. So these values you are able to see, na? Or should I enlarge it?
Visual, sir.
These are visible. Similarly, this is
Visible.
50 year 24 hours rainfall. Now you see there is a ratio given, 1 hour to 1 hour, between 1 hour and 24 hours. So this is a 24-hour point rainfall. If I want 1 hour point rainfall, then the value what I arrive from this sketch will has to be multiplied by a factor 0.42 to arrive at 1 hour point rainfall. Next, this is another map, but here it gives 50 year 1 hour point rainfall. So we have seen two charts where 24-hour rainfalls have been given, and this is a chart where only 1 hour rainfall is given. Similarly, the values which has been given here are not for 1 hour rainfall. It has been given a value which has to be multiplied by 1.15 to arrive at the value of 1 hour rainfall. Now there is another factor which we have seen in runoff coefficient. It was the value of F. F is areal reduction factor. So this depends on the catchment area and the duration of rainfall. So here the duration is, because generally this graph or this report is available where for a rainfall or the duration, which is generally the main water comes within 3 hours. So it is limited to 100 minutes. So this is the duration of rainfall. This is the catchment area, and by this graph I find out the areal reduction factor. Now coming to the only value left over is X. So X value has been provided here. Here this is black cotton soil. This value 0.456. Please also note down on that piece of paper, because in an example where I will explain how to calculate this, I will be using this figure, because that example covers an area where the black cotton clay soil has been mentioned. Coming to this, in case we do not have the areal reduction factor, if we do not have the X, where means the soil value, so if these things are not there, still you can find out the coefficient by an empirical equation which has been mentioned here. But the better is to go by the X, R and F value, because this empirical equation has again used some assumption to arrive at this empirical relation. So better result will be if I know X and F value from the graph or from the table which we have seen above. Now the only factor is left over here is TC, that is the time of concentration. So how TC is to be find out? TC for the Bhatnagar, TC, there is a called Bhatnagar formula. Mainly it is applicable on almost all the entire area except where the terrain is very, very hilly and the slopes are very steep. There, if we use this formula, the runoff the Q50 will come very high, and that therefore it will be uneconomical. For that there will be another. So here TC is L by LQ by H. Again, find out that this TC is the time of the water at the most point on the crest. This is the TC value. How it is calculated? It is calculated by the longest stream L, and H is the height of farthest point above the point of interest. Matlab, from the bridge to the farthest point, what is the height difference, without going for any formula or without going for a statistical slope. We will be using this value. Again, this is a empirical formula, so you find that L is in kilometer, though H is in meter. TC will come in hours. In West Coast and other similar region where the slope is very high, either you have to go for the hydrograph analysis, means go by the synthetic hydrograph method, or use Bransby-Williams formula. Here also L is in kilometer, area is also in kilometer square, but S here is in percentage, means L by H will be the percent in percentage, means both will be in the same unit, and the TC will come in again in hours. So now I have arrived on all the factors which are required in my equation. So I know the work areal reduction factor F. I know the catchment for the catchment area and value of TC. F depends on the value of TC and the catchment area. Then I have to find out the runoff coefficient depending on F, R and X value. Thereafter, here X is left over, means C will be depending on X, R and F. So once we find out this, then I have to find out a R50 TC, means the 50-year rainfall of TC hour duration. How we find out? There will be another graph which I will show you first, so that you will be able to understand this. Again, I will request that on a piece of paper you write only figure 4, and figure 4 has two ordinates, y and x ordinate. On x ordinate there is time. This time is TC, means time of concentration. On x coordinate, on y coordinate indicates a ratio. The ratio is between 50-year T-hour rainfall and 50-year 24-hour rainfall. So this line, 50-year T-hour rainfall divided by 50-year 24-hour rainfall ratio, is on y coordinate, and on x coordinate time is TC. So if I know the value of TC and I know value of 50-year 24-hour rainfall, for which I have shown you that there are different tables, all India map, individual maps. So then by this ratio I can find out 50-year T-hour rainfall. Hope you have understood, or if there is any confusion I will explain it again. Participants, please reply.
Please explain once more, sir.
Once more. So, first, just 1 minute. This graph is on your table. I know the value of TC. Yes or no?
Yes, sir.
TC I have known. So, and on the x coordinate, there is a ratio. This is a ratio. On the x coordinate, ratio has been given. What is the ratio? Ratio is 50-year TC hour rainfall and 50-year 24-hour rainfall. So, this is the ratio. Ratio has already been plotted. You don't have to find out 50 or 24-hour rainfall or TCR's rainfall. So this ratio, this is a graph which is available. This has been drawn and given in the CWC report, in the RBF report. Now I know the TC. I know 50-year 24-hour rainfall, which we have calculated from the graphs which I have shown and which has also been used in deciding runoff coefficient, because runoff coefficient was X, R is a factor between X, R and F. So I know R50 24-hour rainfall, I know TC, I know the ratio. So this ratio multiplied by 50-year 24-hour rainfall will give me 50-year T-hour rainfall. Am I clear now?
Yes, sir.
So the same thing has been written in language, that calculation of 50-year rainfall intensity lasting for TC hour duration will be find out by referring to figure 4. So for TC hour duration, read from the report, ratio of 50-year TC hour rainfall by 50-year 24 hours rainfall. So R50 TC is R50 24 hours multiplied by above ratio. And this R50 TC is required for I50, matlab 50-year intensity. I50 is R50 TC, which I have known, and TC I have already calculated. So I is known. Therefore, the final equation which you have written in the very beginning, Q, is some constant multiplied by C, multiplied by I50, multiplied by A. Now all the factors are known, so I can find out and arrive the Q50 value. Is it clear? Is it clear?
Yes, sir.
Now these slides show that I have already shown you that there will be for subzones, means for 7 subzones, you will find that 50-year 1 hour rainfall value has been given. So only for your information and for your ease, all the data has been collected here, that you don't have to go through all the sheets to find out what is there. So here it has been given that 50-year 1 hour rainfall has been given for these 7 subzones. Next, for these 12 subzones, 50-year 24-hour rainfall has been given. So how to arrive at 50-year 1 hour rainfall? A ratio has been given in those sketches, in those maps, where by multiplying that ratio, the 24-hour point rainfall will get converted into 1 hour point rainfall. Still there will be 6 subzones where neither 1 hour rainfall or 24-hour rainfall have been given. For those zones, you have to use the All India figure where the 24 hours rainfall has been mentioned, where we can find the all India, the first figure which I have shown you, that where the 24 hours rainfall can be found out. That value has to be multiplied by 0.37 to arrive at the 1 hour rainfall value. Why I am always stressing on 1 hour rainfall value? Because RBF 16, while arriving at the calculation, or while arriving at the Q50 result, has used 1 hour 50-year 1 hour rainfall values. You will find, I will explain in the example, that even by using 24 hours rainfall, you can arrive at that value, but then that value will be at variance of almost plus minus 4-5%. And in the discharge calculation, you will find that 4 to 5% variation is not very significant. Means your design of a spans foundation will not get affected by that small variation of 4 to 5%. But it is better to follow the method which has been given in RBF 16 using 1 hour rainfall value, because this is a empirical data, and by following those process there are many assumptions which you get accounted for. And then if you go for 24 hours rainfall, there are certain assumptions which you are skipping, which you are not taking into account for arriving at the data. So I will again summarize before going for the explaining the example what I have done. I have found out the value of area, the length of the longest stream, then the height, the difference between that. Based on that, I have found out the time of concentration TC. Then I have found out the R50 24 hours. Then I have found out the earth, what will be the effect of the earth or the catchment area properties on which the rain is falling. Then I have found the areal reduction factor. Thereafter, I have to find the R50 TC. So again, I will be explaining the intricate method, or the method which the RBF 16 has used for using 1 hour rainfall ratio. So read the ratio for TC hours from figure 4 of the report, page 10. This figure 4 is nothing but what I have already shown you. Then read the ratio for 1 hour from figure 4 of the report. So I will just 1 minute. So this is the figure 4. So kindly also note down that for TC 1 hour, this red line is the ratio. The value is almost 0.37. Write down for 1 hour, the ratio value is 0.37. Similarly, in this graph, you will find one thing I just missed, that these are the lines for which the ratios to be read. These are for zone 1, 2, 3 and 4. For zone 5, you have to use the graph for zone 4, which has been mentioned here. And for 6 and 7, I have already said that the hydrological data and those graphs are not available. So for 1 hour duration, please write down the value 0.37. It is from the graph. You are able to see that? Are you able to see that? And it is for the zone 3. So this is the curve. Here it is 0.37. Similarly, for 3 hours duration, if we will go, this is the zone 3 curve. So the value will be around 0.57 because the graph goes asymptotic. The second characteristic of this graph is that after 3 hours, it has not been mentioned, but you will find that here it has almost become asymptotic, means it has become almost tangent to this, so it will continue like a straight line. So whatever is the ratio for 3 hours will be the ratio for 4 hours, will be the ratio for 5 hours. So even if my TC is more than 3 hours, the ratio will remain as per the value will be almost 0.58. So keep that value also in your diary. That will be used in the example. So here we have used this ratio of 1 hour. Then for the TCRs, we will use the ratio. So the coefficient K will be TCR's duration divided by 1 hour's duration, R50 TCRs by R50 1 hour. Then R50 TC is K multiplied by R50. By that ratio, just 1 minute. The ratio which is there, in the ratio what we have taken R50 TCRs, this is T, by R50 24 hours. I am not able to write clearly, but you should understand this. This is the one ratio. This is one K1. This I can read from graph. Participants, are you with me?
Yes, sir.
So this is the first line which here I have written. This has been mentioned here. Now going for this second line, what it says? It says the ratio for 1 hour from figure 4 of the report to figure 4 of the report. So here it is TCRs. This is for TCRs. So this is K1. This is TC. Okay. Now the second thing, it says this says R1 divided by R24. This is there. So this ratio also I have taken as K2. So if I divide K1 by K2, then this 24 hours will automatically cut down, and the ratio K1 by K2, K1 by so the ratio K1 by K2 is known. So K1 by K2 is known, which is nothing but RTC by R 24 hours. RTC by R 1 hour. R 24 hours तो कट गया. Am I clear?
Yes, sir.
So this is there. So for R50 TC, K1, K2 are known. R50 1 hour is known. So R50 TC can be found out. Is it clear? Anybody has any confusion? Please tell so that I can go ahead. Any participant? Do you have any confusion?
No, sir, clear.
Clear, na? ठीक है. So now I will come for the just 1 minute. I will remove those from the slides. Now the same calculation which I am writing, this is for the Godavari subzone. Catchment area has been given, longest stream L has been given, farthest point length has been given. This is the height difference is 50. Nature of soil is black cotton soil. So how to solve that? So this is the formula. Perhaps all of you have written on that piece of paper, friends?
Yes, sir.
So I am just reproducing that. So now for this C, this 0.456 is nothing but the X value which have been mentioned for the black cotton soil. Because my example or the catchment area property is with the black cotton soil. Then R and F is there. For F, I have to find out the areal reduction factor. Catchment area is known. Duration of rainfall, TC, has to be found out. So TC will be L cube by H to the power 0.345. 11.87 is the length of that catchment. I get a value of 194.8 minutes. It is just 3 hours 24 minutes. As I have already explained that in figure 4, where the graph is there, if beyond 3 hours, if there is a rain beyond 3 hours, or if our catchment, this TC is more than 3 hours, still the value will continue to be equal, the ratio value will continue to be equal for the 3 hours value. Now this area, I have used the All India map to find out the 24 hours rainfall. This is by the latitude and longitude. You will find out where the place of bridge is. As per that bridge, now you can see these value of the isopluvial maps. So this value is, one value is of 200, another is of 280. This value, this value is of 200. The next value is of 240. So between 200 to 240, as per this distance, you will calculate and will find out what is the 24 hours point rainfall at the point of the bridge. Alternatively, if in the another lower Godavari subzone, when you will see the main flood report, CWC report there is also a 24 hours point rainfall data have been given, but this has been given in the alternate main Godavari subzone, the flood report. If you will see that there, that has been given. So anywhere, wherever you will find almost the same value you will arrive. So you arrive into that value, it comes as 25.3 centimeter. Because here it has to be in centimeter. Rainfall has to be in centimeter. So you find out the runoff coefficient by using X value, R value from the graph or from the sketches, isopluvial maps, and the F value, for which I have already shown you a table. So in that table, as per that table, the value comes at 0.85. So using this, you get the runoff coefficient value 8.840. Now, what I was telling you, that TC hours rainfall of 50 hours T hours duration and 50 hour 24 hours duration, means TC hours duration is, here it will be, because TC is 3.4, so I will use 3 hours, and this is 50 years 24 hours, so the ratio is 0.57. You have noted it. At that point when I was showing you the graph, I have mentioned that you please note down that value, that was 0.57. All of you have noted, or anybody has missed?
Noted, sir.
Noted. So next, on the same graph, I have also shown you that you note down the value for 1 hour ratio. So that 1 hour value is also there. 1 hour value also you have noted. So that was 0.38. So if I take a ratio of these two, these 24 hours value will get cut off. Matlab, even if you do not know the 50 hours rainfall, that will go, and you will get a ratio of TC hours duration by 1 hour duration. This is correct. So this value comes as 1.5. Now I know 24 hours rainfall as 25.3, which I have. The second value I will found out by, for 1 hour duration, by another figure 3.6 of RBF data has been given in RBF report. So based on that 1 hour rainfall, I get a value of 92, because I know that R50 TC is 1.5 multiplied by 1 hour ratio. So 1 hour ratio is 92. So 92 multiplied by 1.5 is 138. This is R50 TC. So intensity of rainfall I is R50 TC by TC, 138 by 3.247. This is 42.5 millimeter. So I have received I have received C, I know A, therefore C has been calculated, I has been calculated, A has been calculated. A is in square kilometer, I has to be in millimeter per hour, C is a coefficient. So based on that, that will come as 245.24. There is no query or any confusion till time what we have covered. We have covered RBF report 16, which is for a catchment area of less than 25 square kilometer, and we will find that most of our bridges, at least all the minor bridges and bridges with opening up to 12 meter, means even some of the major bridges which is 12 meter plus opening can be covered and analyzed by this simple method. Now further we come for the flood estimation for medium catchment area. And what is the medium catchment area? Which is less than 2500 square kilometer but more than 2500 square kilometer. just for your information, when you will go for different subzones, then you will see the reports of those subzones. You will find that in certain subzones, this 2500 square kilometer, they have said that you can go up to 3000 square kilometer, you can go up to 5000 square kilometer. So depending on the characteristics, matlab physio hydrological characteristic of that subzone, this area, the higher area 25 square kilometer, has been further relaxed for certain subzones. So first, a simple explanation. What has been written, you can read whenever you require a deep knowledge for the subject, you can read. I will just explain it in simple words. We'll try to give you the concept that this is the time. Here you see the time. This is the discharge. You say this is the discharge. So the time versus discharge graph is the hydrograph. A complete hydrograph shows two things. This deep yellow color shows the normal base flow, whatever is coming from the earth, what is directly not coming from the runoff. And this orange color map which is going, this is the storm runoff. So I have to understand these two things only. When I develop the unit hydrograph or the synthetic unit hydrograph, then if I develop the unit hydrograph, then basically I develop only between these two lines. I add to them the normal base flow, and I also subtract to them the losses which will happen due to the percolation effect. Now the concept of what is the unit hydrograph. Unit hydrograph is nothing but it is if a unit centimeter, unit rainfall, means you say 1 centimeter rainfall of unit duration. Duration is unit, means this TR is also 1 hour. So this is if a rainfall of 1 centimeter and duration of 1 hour has fallen on a catchment, then the hydrograph which it will produce is the unit hydrograph. What will be the characteristics of this unit hydrograph? This unit hydrograph, because of the rains, the discharge will start, it will reach a peak, and then it will again come down. So this is the base of the unit hydrograph. This base, this is the highest rainfall, this is the highest discharge due to this rainfall, and what we will find that there is a time lag, means this is a 1 hour rainfall, it has ended. So from the center of this 1 hour rainfall and the time where the peak has entered, so this is called the TP, this is called the time lag. So this time lag means from the center of the unit rainfall to the maximum discharge value when the hydrograph has achieved is called the time lag. What are the characteristic of this unit hydrograph? So the same thing has been described in different words. It says that it is the hypothetical response of a watershed in terms of runoff value and timing to a unit input of rainfall. It can be defined as direct runoff hydrograph resulting from one unit of effective rainfall occurring uniformly over the watershed at a uniform rate over a unit period of time. This period of time is 1 hour. So what are the basic principle of unit hydrograph? In the graph I will just explain. The unit hydrograph basic principle says that this base period means when the water has started coming in the stream and when it has stopped, matlab the entire water has come into this base period remains the same for that area for all the unit hydrographs, and with the time also it does not change. If it has happened in 2021, if this TS is 13 hours, then in 21 also it is 13 hours, in 19 it will be 13 hours, in 29 it will also be 13 hours. Similarly, this ordinate will be proportional. So consider this QP is 5. This is for 1 centimeter rainfall. Consider this QP is 5 meter cube per second at this step. If it becomes 2 centimeter, then they say it will increase proportionately. Matlab the same graph will increase proportionately. Matlab if it was 5, when it becomes 2, it will become 10. But this time period will remain same. If it is 3, it will become 3 QP. It is 4, it is 4 QP. But this time period TS will remain as it is. So it will just increase proportionately. And the form of this hydrograph or the shape of this hydrograph will not change. The same thing has been mentioned in language here. Storms of equal duration will produce runoff hydrograph with equivalent time base regardless the intensity of rain. The base of the hydrograph of direct runoff of any effective rainfall in unit duration is constant. The ordinates of direct runoff hydrograph of a common baseline are proportional to the effective rainfall. Means what I said, the shape will remain the same, only it will increase. Here, if it is for the unit duration, means if this TR is constant, if it is 1 hour, it will remain. If it is 2 hour, then this again it will change. There will have some another shape of the unit hydrograph. Unit hydrograph is only for 1 hour duration, unit hour duration and unit rainfall. Third, the ordinates will be proportional. And the third is the direct runoff from a drainage basin due to a given pattern of effective rainfall will not change with time. What I said in this year also it is same. 5 years earlier it was also the same, and 5 years down the line also the shape will remain the same. Same thing has been explained in this different color. Consider this 1 centimeter. This is the unit hydrograph. This is 1 hour. So this line is 1 centimeter. This period is 1 hour. So this 1 centimeter rainfall has been shown as in blue color. TB is the base. From here to here it has happened. Now a rainfall of same duration, 1 hour duration, but the value is less than 1 centimeter, x1 centimeter. Then what will happen? TB will remain the same. Only this ordinate will get reduced by this value. So this becomes x1 into q. Here this q, here this q should be a small q. Here this q should be a small q. Q is the discharge. So this will become x1 into q. If this is x2 is more than 1 centimeter, then this red line is the hydrograph where the rainfall intensity or rainfall is more. Instead of 1 centimeter is of x2 centimeter, which is more than 1 centimeter. So this is the graph which has just been exaggerated or just been expanded by multiplying by 2. So this value remains as, if here is the value was q, then this value has become x1 into q, this value has become x2 into q. If this was the highest discharge, then this will be x2 into, here consider this q, instead of q you consider this was 10 cubic meter. then this value will x2 into 10, and if it is 5 centimeter, then this value will be x1 5 into 5. So this will just get reduced proportionately. Could you get what I am telling? Have you understood what I have explained? Friends, reply please. इसमें कोई कंफ्यूजन है तो बताइए. Have you understood this? Again, step by step we are going ahead. So previously here the same thing has been again implied, that if there is a 1 hour rain, this is only 1 hour, 1 hour rain has with rainfall intensity or with total rainfall 1.5 centimeter has occurred on first hour. In the second hour, the rainfall value of 2 centimeter occurred in second hour, and rainfall intensity of 1.25 hours has occurred in third hour. Then how to find out the unit hydrograph for the same sub-basin, because of these 3 rainfalls have been explained in this. So what we will do? First, we will draw the unit hydrograph for all these 3 durations. So the first hydrograph I have drawn, which has been shown in green color. So it has started 0 to 1. It has ended. It is almost 8.5 hours duration. Started from 0 to 1. The second rainfall, in the second hour, again I have drawn the unit rainfall, which has been given in by curve number 2, started from 1, same intensity because it is the unit rainfall, and 8.5 hours because it has started 1 hour earlier. So this black color has gone up to 9.5. Now the third rain, because for this third rain I am plotting, it is 1.25 hours, but presently I am plotting only unit hydrograph, which is of 1 centimeter duration. So the third one, this was the 0 hours से ये पहला शुरू हुआ था, 1 hour में ये दूसरा शुरू हुआ, 2 hours में ये तीसरा शुरू हुआ. तो this is in the pink color. So this 2 hours it has started, it is shown by graph number 3, and 8.5 hours is the total base period. So it will end near 10.5. So it has ended near 10.5. Now the first rain is value, the unit hydrograph is of value 1 centimeter, and the first rain is of value 1.5. Rainfall, the volume of rainfall is 1.5. So this graph, the graph 1, will be increased, all the ordinates will be increased by 1.5 times. So I get a graph 0, 4. But the base period remains the same. Now 1 was for the first hour rain unit hydrograph, 4 is 1.5 times bigger. Similarly, second was from 1 to 9.5, means this was for the second hour. It will be increased by 2 hours. Base period will remain the same for all. So this second has increased to curve number 5. The starting is same, end of 2 is at 9.5, so 5 also ends at 9.5. Now curve number 3. Curve number 3 is 1.25. So the third number will also increase by 1.25 times. So this is the 6th number curve, which is in the black color. The base will remain the same. The base will remain the same. And all the ordinates which will be there, if I want a point at 4.5, whatever is the ordinate of the final hydrograph will be added to get the final hydrograph, which has started from 0 and will end where the last hydrograph has ended at 10.5. So this will be the final hydrograph. This is nothing but 1, 2, 3 are the unit hydrographs. They have been increased or multiplied by the same factor by 1.5, 2 and 1.5. Then the curve which we got is 4, 5 and 6. At any point or at any location, the ordinates of 4, 5 and 6 are added, which comes in the form of this blue color line, which is the combination of these 3 unit hydrograph, and this is my final hydrograph. This is my final discharge, which is coming by these 3 rains. Am I clear? And the same principle will be applied to find out the flood discharge and the design discharge for a catchment area for a particular bridge. Am I clear about the entire thing? Or do you need any explanation further?
Okay, sir.
एक बार फिर से बोलिए, आपने हाँ बोला या ना?
Okay, sir.
ठीक है ना?
Yes, sir.
हाँ, but everybody is requested to switch off their mic. Only the person who wants to reply or ask a query should open it. So should we continue 15-20 minutes more, or we should close?
Continue, sir.
Continue. So what I will do, I will come up to the synthetic hydrograph and so what is this synthetic unit hydrograph? In fact, I have already explained it to you, but on a cost of repetition and to be very, very specific, I will just read it off. So unit hydrograph can be developed for site specific if the rainfall data is available for 5 to 8 years, but collection of adequate data for every site is neither practical nor economically feasible. So a synthetic unit hydrograph of unit duration for a catchment developed from relations established between physiographic and unit hydrograph parameters of representative gauge catchment in hydrometeorologically homogeneous region has been developed, which is called the synthetic unit hydrograph. Is it clear, or should I explain further? Just for your information, how it has been developed. What they have done, when you will go through those reports, you will find that Khosla and other committee, mainly Mr. Khosla was there, who has the biggest mind and had developed these graphs with foreign studies. Foreign has previously developed then, and Khosla was associated with him also. Then he has come here. Then he came back here from Roorkee University. He remained as Vice Chancellor also. Then he developed these entire thing. So the entire catchment there was rain gauges spread over on different area, and those rain gauges data were collected, and those collections were analyzed, and then some empirical formulas were arrived by which they could correlate the rainfall intensity, rainfall intensity duration, and the hydrograph or the discharge which was coming at the rail end. So just 1 minute, just 1 minute. It's raining heavily and my window was open, so a lot of rainwater was coming. I just went there to close it. So sorry for interruption. So that by that way, an empirical relation has been developed, and it was found that there are certain areas which are nearby. They behave in the same fashion. So that it means that empirical relation is available is applicable for that entire region. Then that entire region has been developed as a subzone, and the relationship given. And with that relationship, the synthetic unit hydrograph is developed. So we develop the synthetic. How we find out, how we arrive at the design discharge? We develop a synthetic unit hydrograph depending on the catchment properties, means area, length, center of the length of a stream from center of gravity to the bridge site, then equivalent statistical slope, design rainfall intensity, what duration of rainfall will cause the highest 50 years flood. That is also developed by an empirical formula. By estimating that, we will arrive at. So the steps generally involved is, first, draw the synthetic unit hydrograph, then estimation of design storm duration and intensity. It is being done by some empirical formula. Then estimation of design loss rate and base flow. These two things are already mentioned for each area, and each subzone, both has been decided either through a empirical equation or through some value like 0.5 centimeter per second per square meter is the loss rate, or the base flow is 1.5 cubic meter per square kilometer per second. So these values have been given in the report. Then estimation of rainfall excess unit, because that will decide that my unit hydrograph, how much bigger or how much lower than the unit hydrograph, what will be the size. Size means the shape will remain the same, base width will remain the same, the top portion will remain the same, only its size will increase. If the rainfall is 5 centimeter, it will be 5 times bigger. If rainfall is half centimeter from unit hydrograph, it will become half. Then working out flood hydrograph. So this hydrograph will be each hour how much excess rain has occurred. So for those excess rain, we will draw the hydrograph, and those hydrograph ordinates will be added. What is the highest ordinate will be the maximum discharge by that storm. For that maximum discharge, the bridge is designed. And when we will see the example and we will solve the example, you will find that there is a particular style, or you can say a trick of arranging the data in a single go. You can find out the Q without going for the making the flood estimation, without making the flood hydrograph. Means you don't have to decide all the ordinates of the flood hydrograph, but by a shortcut method, you arrive what will be the maximum value of that ordinate, because you are interested in that. Why other portions are also added? This is required generally because of the confluence. If there are two streams which are coming, so in the main stream maybe the water is low, like in Ganga and Gandak is in meeting at a point, it is at a confluence point. Then if the Ganga is lower than its danger level, but the Gandak is higher than its danger level and it's contributing much water, then the less water in Ganga, less level of Ganga added by the more level of Gandak can cause difficulty. That is why the final hydrograph is necessary for the analysis of the rivers downstream. Otherwise, the maximum discharge which is coming for the Ganga will be good enough for deciding the bridge on river Ganga. So now I will be explaining you the empirical relationship. I will take 15 minutes more than this empirical relationship, and what are these values. I will explain it and will close today. And tomorrow then we can tomorrow we will take the example. कहाँ गया यार? Tomorrow we will take the example of how to solve that and how we will arrive at. So this is a unit hydrograph. This unit hydrograph I have already explained. The y coordinate gives the discharge in meter cube per second. This is the base, or this is the time on the x coordinate in hours. The shape is fixed. For this unit hydrograph, this QP, if this TR is for 1 hour, if this is for 1 centimeter, then this TB is fixed. The shape of this diagram is fixed, means this QP for 1 centimeter rainfall is fixed. In case this, instead of 1 centimeter, it will become 2 centimeter, then this ordinate will get double. Every ordinate will get double, but the time period TB will not get double. So coming back to the physical properties and the empirical relations which we will get in for the unit hydrograph. So W50 is the width of the hydrograph at the 50% of the discharge. If the QP is 100, then at the 50 level, what is this width of the hydrograph is W50, and the width of the rising limb has been mentioned as WR50. Why these values are necessary, I will tell you. Similarly, at 75% of the discharge, consider means 0.75 QP. At 0.75 QP, the value will be 0.75 QP. The width will be W75, and the rising limb will have WR75. These values have got the empirical formula, which we will find in the next slides. So this is for Kaveri subzone, because I am explaining for one subzone, the same will be applicable for all other subzones in the similar fashion. So in this, and each and every subzone will have a different set of these formulas, but all the subzones will have the same. The first column will remain the same for subzone. Only the values, the coefficient, the power, this will change in all subzones. But these parameters will remain the same. So what is TP? TP is time taken from center of rainfall in 1 hour in 1 hour of 1 hour's duration to the UG peak. I hope you are understanding. This is the TR. This TR is also 1 hour. So from the center of this to the highest time, this is the time lag. This time lag TP, this is the TP area. So here this TP has been given L, LC and S. If you have already noted down the catchment properties, all these values, I have said that these values will be required for finding out for drawing the unit hydrograph. Then this QP. This QP means here in the drawing I will change next time. This QP is the same what you see here. This QP and that QP is the same. So peak discharge of unit hydrograph, there is a formula. This formula is based on TP. Then this W50 width, 50% of peak discharge, this is again a formula. At 75% of peak discharge, again empirical formula. 50% width, rising width, this formula. 75% rising width, this formula. Base width, this formula. TM. TM is TP plus TR by 2. What will be TR here? Any person who can say what is the value of TR? Any person? What is the value of TR here? Any participant? कोई बता पाएंगे? यहां TR का वैल्यू क्या है? Any participant? कोई बोलिए? कोई नहीं? कई बार बता चुका मैं, ये TR जो है वो हाँ पार्डन कोई बताना चाह रहे थे, बोलिए. हाँ
यूनिट हाइड्रोग्राफ की ड्यूरेशन.
हाँ बात गुड यस गुड यार, मतलब मैं तो लूज करने लगा था इंटरेस्ट कि भाई कोई सुन ही नहीं रहा है, लेकिन ठीक है आपने बताया. यस, दिस इज ए यूनिट ड्यूरेशन. सो वो जो लास्ट वाला फॉर्मूला है वो आप यहां देखेंगे. दिस TR इज ऑलवेज 1 hour. सो दिस TP प्लस half an hour टाइम यू विल एड. सो दिस इक्वेशन विल रिमेन same almost for all the subzones except for sub-Ganga zone. Perhaps you will not require that much, because in sub-Ganges zone the unit duration has been considered as 3 hours or 6 hours, because in subplane, in the Gangetic subplane, the rainfall intensities are very high. So if I keep the unit hour duration as 1 hour, then the ordinate will become very big and the calculation will become very complex. So they have kept 1 hour, 1 unit of time as 6 hours. So there it will be 3 by 2, 6 by 2 means 3. Otherwise in most of the zones it is TR is 1 hour only. And QP is peak discharge. This QP is discharge per meter cube per second per square kilometer. So in the final discharge is for the entire area, so that discharge will be multiplied by A, you will find the maximum discharge. Now I have said that there will be a statistical slope. So what is this statistical slope? This, in a RBF report, we have gone directly L by H, the distance we have decided and gone. So in the most of the equation, we will go by this statistical slope, and statistical slope has been mentioned by the equation is Li di minus 1 plus di whole divided by L square, where L is in kilometer, Li and d are in meter. So I will explain what is Li and di. Consider, you are seeing the arrow which is moving on the computer screen. Are you able to see the arrow? Yes. So consider that this location, which I have mentioned as D, or looking like a half zero, so this is my bridge location. So consider the elevation of this is something. Then there is a slope like this, thereafter it has increased, then it is going like this, then it has increased, again going somewhere increasing. Hello? Are you getting this? Hello? So this is my slope of the area through which the water is coming. So let us see this portion and let us see this part of the slope, and the similar fashion all part of the slope has to be decided. So here the elevation is di minus 1, or consider this point, consider this point as ith segment. So the elevation is di. What is the elevation, this d? This elevation is the elevation from d. Direct, what is the height here? So this is the height from d to di is the elevation of di. Then come to a lower second point. This is di minus 1. So what is this? This is di minus 1 is again a elevation from d. Means this is the height from d. And the length of this segment Li. This is the length of this segment Li. So the formula is summation of Li multiplied by the sum of these elevation. Similarly, the elevation of these two multiplied by the length this. Similarly, sum of these elevation multiplied by the length this. So this is the formula. And here d and Li are in meter, and the total length, which is L, this is the highest point. Consider this is the highest point. Then this is the length L multiplied by L square, which is in kilometer, is the statistical equivalent stream slope. Is it clear? The same equivalent stream slope we will use in the formula here. This is the S. This S is the equivalent stream slope, which we will find out by this equation. This is the equation here given. You will see the report. This is an extract from the report. This is Li. This is E0, here it is E1, it is E2, it is E3, it is E4, it is E5, then di plus di minus 1 by L square multiplied by Li, and E0, E1, E2 is nothing but the height of the means elevation of those area. The same thing has been explained in earlier chapter. Same parameter, what equation I have shown you here has been mentioned at this location. Only thing you will find that there are few figures which has been shown in blue. Only these blue figures have to be filled up to find out the value of these locations. L is the longest stream, LC is the distance from the center, or from the longest stream distance from the center of gravity to the bridge side. S is the equivalent slope, A is the area, and TR is known, it is a fixed value, it is 1 hour. By that you will get all the ordinates, all the things, TP, W50, W75, W50, W75, WR50, WR75 and TB. These are the locations, these are the values, and the QP. These are the values which you need to find out or draw the hydrograph. The next step, that I have drawn a hydrograph. How will I find that the shape of the hydrograph, because I have got now some fixed points. I will again show you the graph. So I know this QP from equation, I know WR75 by this equation, I know W50 by this equation, I know this. So these 1, 2, 3, 4, 5, 6, I have these 6 points. On these 6 points, the diagram or this curve can take many shapes. How will I know that the shape which I have given to this unit hydrograph is correct or not? There is a small check which I will mention. The basic principle of this check is that I have an area A on which only 1 centimeter rainfall has taken place. So I am not considering what has gone inside the water, what is coming from the earth to my discharge. I am only thinking that there is a surface, area A, on which 1 centimeter rainfall has happened. So I should get a runoff of A multiplied by this, because A is in kilometer. So I have multiplied it, I have converted it into meter, and because 1 centimeter rain is there, so again it has been converted it into meter. So it has become 1 by 100. So A, 1 centimeter excess rainfall on a catchment area A square kilometer gives this much rainfall. This much of discharge I will get. And the volume of surface runoff, this synthetic unit hydrograph. Now you see that here each ordinate is 1 hour. Generally when I draw the unit hydrograph, I take 0 hour, 1 hour, 2 hour, 3 hours, 4 hours. So each unit is 1 hour. So if I take 1 hour and I take this value, then this ordinate multiplied by 1 hour, this ordinate multiplied by 1 hour, this ordinate multiplied by 1 hour. So basically the area under this graph gives me the surface runoff. Am I clear? The area under this graph, the area covered by this gives me the surface runoff. Anybody has any confusion? Any person has any confusion? Please tell me. This is the basics on which we will further go ahead. किन्हीं को कोई confusion तो नहीं है ना?
No, sir.
So this, if I add all those ordinates and I get a summation of that ordinate as Q, that summation of ordinate is meter cube per second, because the x ordinate has been with Qmax, and the y ordinate is with the Qmax, and x ordinate is in hours. So 1 hour duration I have converted it into second. So it becomes Q into 60 into 60 meter cube. Because it is in second, it is in hour, so both will be multiplied. That will become Q into 60 meter cube. Both the runoff should match, because synthetic unit hydrograph. shows me that 1 centimeter runoff, 1 centimeter rainfall of 1 hour duration, how much runoff it will give. And by simple calculation, that 1 centimeter rainfall on A area has given, so it is giving me this much rainfall. So both the equations are equated, and if I find that the summation of unit the sum of the unit hydrograph is equal to the A by 0.36, 1 by 0.36, sometimes you will find it will come as 2.78 value, 2.78 A, then my shape of the hydrograph is correct and I can further proceed with that. Clear? And if I find that this is either more or less, or it is not matching, then I can change the unit hydrograph. Matlab, I can change the shape of the unit hydrograph, but generally we change it, the points are not changed. These points which are there are obligatory. Generally this limb is, instead of this, you can make it a bit higher. You can make it a bit higher to increase the area. You can make it a big lower to decrease the runoff. Are you getting my point? Like I will take a pointer to make it clear. That will be better. In case I find that my area, what this area is, this hydrograph is showing me excess discharge. So I want to make it lower. So what I will do, I will draw the curve going like this. So the area will decrease. Area will decrease. If I find that the discharge is coming less, so I have to increase the area, but this and this point are fixed. So I draw a curve like this. So the area has increased by this much quantity. So by generally after this W50 area, the things are changed. But all these points which has been marked by circle are obligatory point. All points have to be covered. Correct? Same thing has been mentioned here. If there is a difference, then the falling limb of hydrograph may be suitably modified without altering the points of synthetic hydrograph, such that the sum of all the ordinates under the UG is equal to theoretical value as computed. Without altering the points of synthetic parameters means जो फॉलिंग लिम्ब है उसको आप थोड़ा बहुत ऊपर नीचे करके करें, लेकिन जो ऊपर तक आता रह रहा है उसको आप चेंज ना करें. ठीक है.